Hi, let's talk about this problem. We are given a string. Our task is to check whether the string is palindrome or not. And we need to do it using recursion. A string is called palindrome if it is same when you read it from left to right or you read it from right to left. For example, this string is a palindrome. If you read it from left to right, it is A, B, B, C, B, B, A. And if you read it from right to left, this is A, B, B, C, B, B, A. Same. Basically, if you reverse a string, then the reverse of a string is same as the original string. Then it is called palindrome. Now, if you see this example, here also it's a palindrome. If you reverse it, you will get the same string. If you see this example, if you reverse the string, you will get SKEEG, right? SKEEG. And this string is not same as this string. So this is not a palindrome. Now please pause this video and try to write down a function that takes a string as an argument. And this function is recursive and this function returns true if the string is palindrome, otherwise returns false. Let us now talk about recursive solution to solve this problem. In recursive solutions, we need to think in terms of solutions of smaller problems. We need to assume that we have solutions of smaller problems and then we need to see whether we can use these solutions to solve the overall problem. In this problem, if I compare first and last characters and if I assume that I know the result for the smaller problem, which is from S1 to Sn-2, excluding first and last characters, then I can solve this problem recursively. So there are two things I need to check for the whole string. First and last characters should be same. And this substring from S1 to Sn-2 should be palindrome. If these two conditions are true, then the whole string is palindrome, otherwise it's not. Let's now talk about base cases. So if we are solving for the corner characters first, then we are recursively checking the smaller substring and then it will recursively checking for smaller substring. What will happen? You will ultimately end up with one of these two base cases. Either the string length will become 0. It will happen when you have even length string. For example, if your string is A, B, B, A, you will check for A, then you will check for B, and then you will have empty string in the middle. So you will make a recursive call for empty string. And when the string length is even, say A, B, A, what will happen in this case? You will check for A and then you will call for B, which is a single character, right? Let's talk about bigger odd length strings, say CAB, AC. You will recursively call for this substring. Then you will recursively check whether, these two characters are same or not. And then you will recursively call for this substring, and this substring is of length 1. So you will end up with two corner cases. Either the length of the string becomes 0 or length of the string becomes 1. And in both these cases, we need to return true. If our string is empty or string has one character, then we consider it as a palindrome. Now please pause this video and try to write down complete function. You mainly need to write this function is palindrome that takes a string as an argument and two indexes as argument. So if you're programming in Java, you need to write function this way, and if you're programming in C++, you need to write this way. Bool is the data type as a return value. The string we pass by reference for optimization purposes to avoid string copy in C++. In Java, it's anyways by reference. We pass two extra parameters, start and end, and these parameters are initially 0 and n-1. So what are we going to do? We are going to compare the characters as start and end, right? Current start and end. And then we are going to make a recursive call for start plus 1 and end minus 1. Now you have complete idea. You can fill the rest of the code. Let us now take a look at the implementation. We have C++ implementation here, and this side we have Java implementation. So what are we doing in this recursive implementation? We are checking the characters as start and end. If they are same, then we are checking for substring from start plus 1 to end minus 1. Please note that this logical AND operator works in a short circuit way. So if this condition becomes true, then only it's going to make a recursive call. If it becomes false, then it's going to return false, right? Because logical AND means if the first thing is itself false, there's no point checking for the other thing, right? Because the result is definitely going to be false. That's what is called short circuiting. It happens in both C++ and Java. So if last two characters do not match, we are not going to have a recursive call, right? And we are going to have a result in theta 1 time, because if the last characters themselves do not match, there's no point making a recursive call. So this is how this recursion is written. We check the corner characters, and if corner characters match, then we are making a recursive call for start plus 1 and minus 1. How does this base case work? See, when we are having an odd length string, we are beginning start as here and end is here. Now we make a recursive call, so start is here and end is here. Now we make a recursive call, so start is here and end is here. Start and end, they both are same at this point. So when they are same, it means we have only one character left in the string, and one character means it's a palindrome, so we return true. Now let's see the even length string. Start is here initially, end is here. They're matching. So start is here and end is here. They are also matching. Now start and end cross each other. Start was here and end was here. Now after you do start plus 1, start comes here, so this becomes your start, right? This becomes your start and this becomes your end. So you pass this index as a start index and this index as end index. This means they cross each other. So in this case also we need to return true. So we have written both the cases in single if condition. If start becomes greater than or equal to end, then we return true, right? That handles both the cases. Let us now talk about time complexity of this solution. If we take a closer look at this recursive solution, we can notice that in the worst case, we will be checking every character exactly once. We will be checking the last and first characters first, and then second last and second character, and so on. So every character is being compared only once. So overall time complexity is theta n, worst case time complexity. In the best case, corner elements do not match, corner characters do not match, we immediately return false. So we can say time complexity is big O of n. Another way of figuring out time complexity is writing this recurrence, right? We are checking for the corner characters, we are reducing the length by 2 and checking the corner characters and doing this if condition check, that all takes constant time, right? And then we are making a recursive call for tn minus 2. So our recurrence is tn equal to tn minus 2 plus theta 1. And if you solve this recurrence using recurrence tree method, you will notice that the time complexity is theta n, or big O of n. Theta n is the worst case. Now talking about auxiliary space, see, we are making a recursive call for length n minus 2. So if string length is say 10, then you will have this recursion call for 10, then you will have recursion call for 8, then you will have recursion call for 4, then 2, then 1, right? So, and after 1, at 1 you will return. So how many recursive calls you will have in the function call stack? You have 5 recursive calls for 10. So you have around n by 2 recursive calls in the function call stack, and n by 2 is theta of n, right? So in the worst case, it will require theta n auxiliary space, this recursive solution. So we can say it's big O of n recursive auxiliary space, right, for the recursion, and this is this much time. Again, the auxiliary space would also be big O of 1 in the best case, when the first and last characters themselves do not match, right? You call the function only once, there are not many functions in the recursion call stack, and you just take the constant auxiliary space to decide that that's not a palindrome.